Hello and welcome back, guys. So in this particular session, what we'll be doing is that we will be basically learning about matrices. So let's have a look here. So basically, what is matrices anyway? So a matrices, it's a plural word. Okay, it's a plural plural word, but a matrix is a singular word. Okay, so it's a singular word. So don't be confused in that. So it's basically a rectangular arrangement of rows and columns. Rectangular arrangement of rows and columns. Okay, so this is how a matrix looks like. It's square, right? And then it's usually denoted by capital letters. So basically, A equals to uh, A, B, C, D, right? So the inside portion is small letters. Outside portion is basically capital letters. Okay, capital letters. So it's basically nothing else but array of number. Okay, so it's basically arrangement of numbers into rows and columns. Very simple, right? So there are different types of matrices. So some of them are, let's have a look. So null matrix is basically a matrix where all the elements are basically a zero. Okay, so all the elements are zero in that case. So let's just scroll down a bit. Let's clear our this thing as well. So it's a zero matrix, which just means that everything will be zero here, as you can see as well, right? Everything over here is zero. Similarly, if you see unit matrix or identity matrix, so they are a bit different. Okay, they can be of different sizes. Okay, so normally what happens is that 1001. So the diagonal is basically it's not zero, but it's one. Okay, it's unity. So in unity in math is always one, right? Always remember, don't get confused with that. So unit or unity is basically one in mathematics. They are also known as identity matrix. So basically, all you need to figure out is the diagonal is one, the rest is zero. Okay. So similarly, in a 3 by 3 matrix as well. So why am I saying 3 by 3? Three rows, three columns, right? That's why it's 3 by 3. So it's always row into column. So 3 by 3, 2 by 2. Okay. So 3 by 3 matrix. What happens is that basically the diagonal is one, the rest is all zero, right? So if you see over here as well, so the diagonal is one, the rest is this, all this is zero, right? So similarly, what we have over here is basically a equal matrix, right? So in equal matrix, what happens is that basically they have equal, they are equal, but how are they equal? Basically, in order to for a matrix to be equal, what needs to happen is that they have to be of same order, 2 by 2, 2 by 2. Okay, so if you say, is this matrix and this matrix same? No, it's a big no because this is 3 by 3, this is 2 by 2, right? So that's not same. So what needs to happen is that another thing also that should be satisfied is that the element of A and the element of the other matrix should be in the same position. So if you see over here, so if you see in this particular example, what needs to happen is there should be 5 over here, there should be 5, okay? So there should be 14 over here, there should be 14 over here as well. Okay, so that's how it should basically work out. So you can also refer to this element as basically uh, B1 and then 1. Okay, so this can be referred to as B21. Okay, so this is basically what this that we remain that defined is that B11 is basically B first row first column. Okay, first row first column. B21 is second row first column. Okay, first column second row, right? So that they should be same. Okay, so that's what I mean. Actually, the element should be element in the position. In the position, don't forget that in the same position should be same. Then only what happens, they satisfy this requirement. That's only when they are equal. Okay. So in order for a matrix to be equal, what needs to happen? The order. What is the order? Order is basically nothing else but the number of rows and columns. Okay. So the number of rows and columns should be same in order for them to be equal, right? So order is this 2 by 2, 3 by 2, 1 by 2, right? All these things, okay? So next thing that we should be looking at is multiplication of matrix. So it's always a good idea to show it to you in this thing over here. What I will do is that, so multiplication of matrix. So let's say you have 1, 2, 3, 4, right? 2, 3, 4, 5. Very, very important topic. 2 by 2, 2 by 2. So first thing that you should always look at is basically this thing over here. The column of first matrix, the row of second matrix should be same, okay? Otherwise you can't multiply it. That's always the rule. See over here, this is also 2, this is also 2. Then you can basically multiply it. Otherwise, if no, then you can't multiply it. As simple as that, right? So whenever you're multiplying, what you do is you first of all multiply it with the row to your column. Let's see how we do that. So basically, let's create a new matrix where what happens is that basically you'll have a 1 because that's your first element, right? Into what you do is you multiply this, the first row, first column, right? First row, first column element, you multiply it with that into 2. And then you do plus because since this is a plus figure, right? That's why we're doing plus 2 into. So I told you, so like horizontal multiplied by, it multiplies the vertical, right? So what you need to do is the second element, or let's say A 1, 2 multiplies B 2, 1, okay? Second row, first column, right? So 2 into 4. Similarly, if you were to do it for like, because see what happens is a new matrix which gets formed after this is basically 2 by 2. How did I say 2 by 2 by 2? Is basically see the number over here, the front number and then the last number, that will be a new matrix. New matrix, okay, that's how it will form a new matrix. So what you need to do over here is, so 1 into, again, the same row, you multiply the column, right? 1 into 3 plus, don't multiply it by with 1, multiply it with 2. Once 1 multiplies the element over here, its job is done. You just don't need to worry about it. Just do the second one, okay? Plus 2 into 5. Similarly, down below as well, horizontal multiplies the vertical. So 3 into, what is the first number? 2. Do we multiply it with 3? No, we don't multiply it with 3. So what do we multiply it with? Multiply it with 4. 4 into which? 2? No, 4. What about this? 3 into 3, right? Not 2 because this thing has already been multiplied over here. So what needs to happen over here? Is it 3 into 3 again? No. Its job is already done over here. What we need to multiply it with is 4 into 5. So always remember, so you just don't need to worry about the calculation. So 2, 4, 6, 8. 1 0 0 1, right? So always remember that what you need to do is you multiply it with the row and then the column of the second another matrix that you're multiplying it with. Okay, so first of all, what you do, you multiply it with 2 into 1, 2 into 1, and then 4 into 0. Okay, so similarly for uh, 6 into 8, what you do, you multiply it with that and then with 8 again. Okay, but always remember the order. So this will be very helpful for you. What happens is that the numbers should be same. Of the column of the first matrix and then the row of the second matrix should be same for it to be multiplied. And then when it is being multiplied, what happens is you can just make a blank matrix. Okay, what you can do is just write the order as well. It will be very helpful if you just write the order itself. So what happens is, so since this and this are common, right? So what happens? It forms a new matrix. Okay, 2 into 2, and then you multiply it with the row and then basically the column of the second matrix, right? You do for that, and then after that you again do the same thing for this part, and then now the below part is basically you multiply this with this, and then again this with this, right? So I'll just make it to even more clear with this. And what I want to do is basically 3 0 1 0, right? So what's the matrix over here? 2 by 2, right? So 2 1 0 1 2 3. So 2 into 3. Can we multiply this? Leave the answer in the comment below. Yeah. So how can we multiply this? So if it is possible as well, how can we multiply it? Right, that's the big question over here. So see, this number and this number is common, right? So basically 2 and 2 is common. So basically it can be multiplied, right? What will be the new matrix that will be formed? It will be of which order? I told you this and the last thing, because these two are just used for checking like whether it can be multiplied or not. Once it determines that it can be multiplied. So what will be the new matrix, right? So since there are 2 by 2 element over here, and then this is 2 by 3. So what can be done, right? So it will be 2 into 3. Okay, so first element from here, first row from here, and then the column from here. Okay, so that's how you basically figure out how what the new matrix will be. Okay, so let's try multiplying this one. So I told you first thing first, so 2 by 3, right? So what will happen? You will have 2 rows and then 3 columns, right? Let's just make it bigger here. 2 into 3. So in order to multiply, I told you the row into column, right? So let's do that. 3 into, what should we do? 3 into 2, right? We don't have any doubt in that. Again, 3 into 2, no. 0 into 1. Next element with the next element. Okay, so since we don't have any other number, we can just leave it out. Okay, so over here again, what will happen? The row will multiply the column. 1 into 2 plus again 1, no. 0 into basically the other element as well, 1. So what about the second column over here in the new matrix, right? So let's say this is A, this is B, and then this is C, right? So what needs to happen? The row should multiply the another column over here, right? Let's talk about that particular column now. So 3 into 1 plus 0 into 2, right? And then again down below, what can happen is basically this row into again the same guy over here, right? So 1 into 1 plus 0 into 2. Right, again for the last one, what can we do? We can basically, again for the last one, what can we do? For the last one, what we can do is basically this multiplied by the last number over here, right? So what was the number? Let's just say it's 0, right? So let's just multiply it. 3 into 0 plus 0 into 3. What were the below? So row and then column, right? So 1 into 0 plus 0 into 3. So after that, you just add it up and then you have your new matrix, right? So you might be thinking, I'll just give it to you another problem, which is a bit triggering as well. So let's just say 1, 0, 0, 1, right? So this is 2 by 2 matrix, right? So what if you have like 1, 0? This is 2 into 1, right? So what will happen? What will happen? What will happen is, let's say this matrix is A, this is B. Our new matrix that will be formed is C, right? First thing we should see is that these two are same or not. The column part of the first matrix and then the row part of the second matrix, right? Is it same? Is it same? Yes, then we can multiply it. Right. So once we confirm that it can be multiplied, so what will be the order of the new matrix? New order of new matrix, because we are forming a different matrix called C, right? It will basically be the row of this first matrix and then the column of the last matrix. Okay, so 2 into 1, that will be our order, right? So what we will do is that, so C equals to, always create a blank one, does not matter, right? Just watch out for the spaces, but always remember the order. Okay, always write the order. Very, very helpful for you. Whenever you get confused as well, it will solve your problem. Okay. So first of all, what we need to do is we multiply it with the row to the column, right? So what do we have over here? 1 into 1 plus 0 into 0, right? A row with the column. Same thing over here as well. For the second part, second column, second row, what we need to do is 0 into 1 plus 1 into 0, right? So since we don't have any other element over here, right? So since only it is 2 by 2, and then since this one is only 2 by 1, right? So we are forming only 2 into 1 matrix. So we just don't need to worry about, because see, what we used to do earlier is that we had like many other elements, right? Over here, like many other columns over here, like such kind of thing. So over here we only have one column. So what we'll do is we'll just be multiplying with just uh, these two number and that. Okay, the row with the column. So since we don't have the column part over here, so since we don't have this much part, right? So we just ignore it in our case. So don't get confused in that. People get very much confused in this. Even I used to get confused when I was learning, right? So always remember, if you write the order, you should be good. Always, 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 always write the order. Okay. So once that is out of the way, let's have a look at two problems. I have given it away as well. So I'll be providing this as well if you need it. So you can see over here how the multiplication is done over here as well, right? So this is it might be a bit confusing, but what happens is the row basically multiplies the column and then it forms a new uh, row and column over here. Okay, so the C11 is basically C11 is basically all this thing. Okay, so it's this into this plus this into this plus 813 into this, all right, plus 814 into B41 all that is done. That's how C11 is formed. Okay. So if you see over here as well, 4 and 4 is same, right? That's why it can be multiplied. And then 2 by 3 will be the new order of the matrix. So 2 rows, 1 row, second row, first column, second column, third column, right? So 2 into 3, right? So based on that, we have computed this. Okay. Once that is also done, what we can do is we need to talk about properties. Okay, so they are not commutative. That just means that AB is not equals to BA. Okay, so they are not commutative. Another thing is they have associative property. That just means that AB into BC, if you put that in bracket, if you multiply AB first and then C, and otherwise if you just multiply BC first and then put the AC outside, right? So you first of all multiply that and then after that whatever the resultant is, so what you do that, you multiply it with A, right? So that will be same. Okay, that's called associative property. It also has a distributive property, which just means that so if you take common, or what you can do is AB is basically first of all added up and then you multiply it, right? That will be same as if you multiply AC plus BC. Okay, so if you multiply AC first and then you add BC to it, it will be same. Okay, that's called distributive property. Another is unit matrix. Is basically if a unit matrix is basically multiplied, what is a unit matrix? 1 0 0 1, right? So what happens is whatever you multiply it with, you will get the same value. Okay, so if you multiply it with the matrix, say A, right? So I'll just show it to you as well. Why not? Let's say 2 3 4 0, right? 1 0 0 1, right? So if you multiply this, what happens is 2 by 2, 2 by 2. So you should get a 2 by 2 matrix. I'll just be doing it directly. Okay, so 2 into 1 is 2, 3 into 0 is 0. So that just means it's 2, right? So 4 into 1 is 4, 0 into 0 is 0, so 4, right? 2 into 0 is 0, 3 into 1 is 3, and then 4 into 0 is nothing, 0 into 1 is 0, right? What the hell? Where did I make a mistake? Four into 0 is that. What we should do over here is that let's just say this is 5, yeah? Then what happens is that basically this will be 4 into 4, 5 into 0, right? So 5 into 0, and then this will be again 5, yeah? 5. So if you see, we were multiplying with A, which was basically nothing else but this matrix, right? 2 3 4 5, right? So we multiplied with I, right? So which is the unit matrix. What we got is A itself, right? That's how it basically happens. Okay, so you get the same number if you multiply it with that. Okay, so if you multiply it with A into I, you will be getting A itself. So that is basically known as that is the properties of matrix multiplication. So always remember what happens is basically AB is not equals to BA, and then AB, if you multiply, so it's an associative property which just says that. So ABC are three matrices, and then if you multiply AB first and then you multiply C, that will be equals to basically A, and then if you multiply, if BC is first multiplied and then multiplied to A, then also it will be same thing. Okay, so AB, A plus B, and then in bracket, if you multiply that first, I mean, if you add that first and then you multiply it with C, it will be equals to A multiplied C plus B multiplied C. Okay, So same for unit matrix, whichever matrix you are multiplying it with, you will be getting the same matrix itself. Okay, so if you multiply any matrix to unit matrix, what happens? You get the same matrix. So let's have a look at transpose of matrix. So what is transpose of matrix, right? So transpose of matrix is nothing else but it's simply nothing else but it's just interchanging of rows and columns. What does that mean, right? So suppose this is your matrix. So it's of 2 by 3, right? So what happens if you transpose it, you basically denote it with K dash or KT, right? So what happens is that basically you interchange the rows and columns, okay? So the rows and columns will be changed, right? So since this is column, now this will be a row. If you see over here, so 2 by 3 will be 3 by 2, okay? So similarly, what happens is that the the row over here will become the column, right? So what happens? You need to change the matrix itself as well. So 2, 3, 3, 2, right? So what happens over here? 2, 3. So you can basically take the row, put it as a column, and then after that, put this as a row. Okay, so this is how it will change. Okay, so similarly, in this case, what has happened is that even though it's a 2 by 2 matrix, you will still be getting 2 by 2 matrix, but still the inside element will be changing. Okay, always remember that. That is always very crucial. So that is basically a transpose of matrix. So if you have a proper look at this particular example, you should basically figure it out. Okay. So this example, see over here, 293 was row. Now we made it into a column over here like this, right? So this was a row. What happens? This basically became a column over here, right? So that's the difference. Okay. In that case. Now what we should be doing is that we should be looking at some properties of transpose of matrix. So if you have a look at the properties, what happens is that basically uh, b dash, and then if you do the dash of it, you will get b. Okay, so a plus b dash will be a dash plus b dash. So that's just saying like mm, a dash, basically a plus b dash just means that it belongs to a as well plus b as well. Okay, so RA is basically a real number. So let's just say you have a matrix 1, 0, 0, 100. And then if you are multiplying with 2, and then that's the whole matrix, and it's a transpose of it, then that just means that 2, 1, 0, 0, 1 will be basically these two are same, right? Why? Because of the that's the property of transpose. Okay, so even though the 2 is a transpose, 2's transpose is nothing, right? Because um, it's a real number. So what happens is its transpose will be nothing. Okay, whereas the matrix transpose will be something, right? But in this case, what has happened is that the whole of the real number plus the matrix is a transpose is basically equals to real number and then the matrix transpose. Okay, so same thing over here. Another thing over here is basically a plus b dash will be equals to a dash plus b dash. Okay, so the whole transpose is basically equals to the single transpose and then the single transpose of the another matrix as well. So another thing that I should be showing you all is basically everything is pretty easy after this. If you see over here, the product thing as well, it's just the same thing, right? We are not doing anything else. The row will be multiplying the column. The row will be multiplying the column, right? And then basically the row is multiplying the column. So what you do is 1 into 4, 2 into 5, 3 into 6. This is what is the thingy over here. is basically 1 into 3 is our order, right? What is the order of this matrix? Is basically 3 into 1. So 1 into 3, 3 into 1. These two are common. That just means it can be multiplied. And then what will be our new matrix that will be formed is basically based on this order, right? So 1 into 1 will be our matrix. If you see over here, 1 into 1 will be our matrix. So it just means that it will be a single number, okay? So it should be bracket 32, okay? Should not be a 32 like that. It should be within a bracket. Let's just correct that as well. Okay, now it's, I think, a bit more clear, and then you can understand it as well, right? So similarly over here, what has happened? Let's look at the order first of all, always 2 into 1, right? So since the column is only 1, row is 2, 1, 2. And then over here, the thingy is basically 1, the row is 1 into column is 2, right? 1 row, column is 1, 1 into 2. So 1 and 1 is common. That just means it can be multiplied. 2 into 2, that just means that will be the new order of our matrix. So what happens is that basically you multiply this number with this, and then 1 into 6, not 1 into 6. Oops, where is the erase? Now it's working. So what you do is basically you multiply 9 into 4. Okay, so since there are not any elements, so we multiplied with the row, right? So even sometimes I made a mistake, right? So I did not see whether that is a row or a column. Okay, so always think. So what do we multiply? The row into the column, right? So our row is only one element, only 9. If you see 1 as a row, that's a very big mistake, right? So 9 into 4, row into column, and then after that, what we do, again row into column. That way, what we got is 9 into 4, 9 into 6, and then this is again another row, right? So another row will be multiplying the column, then again another row will be, basically this row will be multiplying that column, right? So 1 into 4, so you got 4, 6, okay? It's that simple. So what else should we be doing? Mm-hmm. So that's just a bit of uh, information about it, right? So after that, it's just more about problems and all. So I will be doing that in the next uh, video. So that will be for this video. I'll see you in the next one. Take care. Bye bye. But if you have any confusion, do let me know. Bye bye.